Hi, good evening, and welcome to this FoodSense Generation 4 weekly webinar. So we do this in order to answer technical questions that are coming during the week. We collect them up and then we kind of go through them and answer them here. So today's the 6th of October 2024, and I will go quite quickly because time is always your most valuable asset. So just out of interest, this won't all be talk. I do have definitely a FoodSense Generation 4 in front of me. And in fact, I will be testing with the FoodSense Generation 4 very shortly, sometimes called the Scoville meter online. It's really a very rapid Scoville meter for testing the Scoville heat units of products. One of the questions was whether this is an analytical system or a screening system, and I will answer that question. But just to say, if you are a FoodSense Generation 4 user, everyone gets personal online training. We definitely did 2 sets of training last week. Really happy to do that. And we do weekly webinars. Hey, welcome to the weekly webinar. Here we are. And we also do monthly webinars as well. So today I will be actually showing the capsaicin fingerprint that this instrument, when I say this instrument, I should put my hand on it really, that this instrument records. But I'm not going to go deeply into where those this fingerprint comes from, but that is covered in the monthly webinar. That said, actually the monthly webinar is on the 24th of October, so really only 18 days, less than 3 weeks from now. We always do one in the morning, one in the afternoon. The one in the morning works really well for India, and the one in the afternoon really works well for the USA. So depending on where you are, there's always a monthly webinar. I'll try and put a link underneath the video when it's gone live, and you'll be able to find your next upcoming webinar. So questions this week. Can we use it? Is it able to measure the hotness in sauces and paste? And they say oily. So I'll do a quick demonstration on that shortly. Question number 2. For example, they don't use the word resolution here, and they use the word difference. For example, kind of 1% difference in red chili in my formulation. Will this device detect that in the finished product? I will not give you an opinion. I will use mathematics to actually answer that question. So wait on for that. Question number 2. Capsaicin and dihydrocapsaicin differentiation in FoodSense Generation 4. How specific it will be to capsaicin? It's actually measuring capsaicin and dihydrocapsaicin. And I'm also going to show you some maths as well, also to sort of give you a sense of if a product is 100% capsaicin, what is the Scoville heat unit? If a product is 100% dihydrocapsaicin, what's the Scoville heat unit? What happens if that product is 50-50 capsaicin dihydrocapsaicin? What happens if it's 70-30 or 80-20? You're going to start seeing that it actually makes very little difference what the ratio between those capsaicin and dihydrocapsaicin actually is on the final product. So I'll do that as well. Then the good thing about Zimmer Peacock is we are the developers, manufacturers, the guys who troubleshoot this FoodSense Generation 4, but we're actually really quite good at a couple of disciplines, and one of them being physical chemistry and also analytical science as well, and probably math in general. So you'll see us bring in a lot of sort of mathematical models in, or just easy sums. Maybe mathematical models is overplaying it a bit. Somebody's asking how reproducible and reliable are the results, and I'll give you an example of that. How do we line up with current HPLC methods? I'm going to show you that we have a 0.99 regression coefficient with HPLC, but I used to kind of say, oh yeah, it's what we're discovering is HPLC from lab to lab is very different, and I'm going to show you an example of that today. So if people want to use HPLC and they only believe in HPLC, then I definitely think that they should use HPLC. But the reason that the FoodSense Generation 4 exists and actually we sell it in such volumes is because everyone knows there's a problem with HPLC. The problem starts with, effectively the cost. But even if you could afford a HPLC, either getting it done by a third party or doing it yourself, it's slow, it's expensive to own, it's full of organic solvents. And it's actually a bit of a black box to people. So you're going to see that this is very highly transparent. So I will address question number 3 today. How do we line up with HPLC methods? And then, is this method acceptable as reportable by international spice trades? I'm not sure if they are, and I suspect not. There's the AOAC methods, and you've also got the ASTA methods. These are HPLC methods, and though we correlate with them, we're not like an official ASTA method. So you could possibly describe it as screening, but I'll dive into that a little bit deeper as we go along. First thing I'm going to do is actually, question number one was sort of asking, well, could we do pastes, sauces, and then they had brackets oily. So I thought, well, let's do a quick demonstration actually of this. This is, if you want to get results that are reliable and fast, then the FoodSense Generation 4 is probably the system for you. I'm just thinking aloud as I go a little bit here. What I'm going to do is I'm just going to prepare a sample. I'm just going to take some chili oil, which I've got here. I'm just going to take a quick sample of that, which I am doing now. So I've got the oil, obviously, not obviously, but I have it in this vial. I'll just put that down for 1 second. So let me just get a bit more of that oil out, actually. Right, what I'm now going to do is I'm thinking aloud slightly. I'm just going to get some buffer. So I'm just going to do what's called a 1 in 10 dilution with that. And then you'll see me probably use my Vortexer next. Don't think of the Vortexer as a very expensive piece of kit. You can get a good Vortexer off Amazon for about $100. It's just oil and buffer, which I've just put in there. You can see the oil sort of sitting down there at the bottom of that. So I want to vortex that up so I can just make sure that I essentially extract all of that capsaicin. So just give me a second while I figure all this out. Right, so I take the sample, which is being 1 in 10 diluted. I'll just vortex it like crazy. So here we go. I'm also going to give it a bit of a shake as well, because I want to really get the oil off the bottom of that. So it looks like this at the moment, but I'm just going to give it a bit more of a vortex. Right, there we are, that'll do. Right, what I'm going to do is I'm going to put 50 microliters onto the sensor. I can't quite remember if that was a clean sensor that I just, yes. Excuse me, probably a bit of capsaicin getting into my throat there. I'm just going to put the sample on and we'll do a quick test. I'm also going to do another test after this as well, so let me just get there and get this test done. 50 microliters onto the sensor, which I am doing. Let me just bring in the app. Everything runs off my smartphone. I just want to, I'll just probably hit continue actually and just go start. So it's pretty quick to start this thing. It's just running the test now. I'm not expecting, and in fact, coming into those other webinars would be super useful for you if you ever really want to understand the science or see the science of what this unit actually doing. It's just doing the analysis now. And while it does that, I'm just going to put that down because I might start thinking about also running another sample as well. So let me just take this. This is just because it's a source. This particular source is just easy to handle when you're trying to do a live demo because it's already quite thin, if I can sort of say it like that. So I've got a result on that. So I'll just put that down for a second. It's come back at 498 Scoville heat units. This will become quite interesting to you because, especially some of you who are trying to sort of validate, does this thing work or not work kind of question. Now, I would super argue that there's a really good level of transparency to this device, more so than any kind of HPLC testing that you would otherwise have done. Because with HPLC testing, you're basically making up samples, you're sending them out to a lab, and you believe the result coming back. Sure, why would you not? But it is actually in part a belief system because you don't have any first-hand evidence on this. Whereas with this oil, I can see a few things. I can see who did it. I can see the name of the sample. I can see the date. I can see the time. This time is called Universal Coordinated Time. So it's by Universal Coordinated Time. It was done at 1922. Today, the 6th of October 2024 by me. And I can see this is actually quite mild. If you don't have a sense of Scoville heat units, then 498 Scoville heat units, which is recorded up in the web but it's also on my smartphone as well. So I'll just change that to here. In fact, I will do that. So yeah, there we go. 498 Scoville heat units. So you get a nice simple answer on the phone. You know, that is just something you can write down. But you also get a result saved in the cloud. This is really kind of important. And I get the raw signal. This will become significant in a minute when you actually see me do a bit more tests, because I can look at that and I can see it. I mean, by eye you would say that's not that much capsaicin in there. Just out of interest, I'm looking at this over here and I can see what's called peak 1 here, peak 2 and peak 3. This is the fingerprint for capsaicin. But this chili oil is actually quite mild, and you will see the significance of that statement in a minute. Well, I've actually got this up. I might actually show you a few more sort of interesting. If I just take a few samples here, puree 17, puree 16, puree 15. These are just, I'm just randomly pulling these out, but this is the cloud system that all the data actually gets automatically saved to. And I'm just going to compare some old data, and I can do a comparison. I can see these different samples and what their Scoville heat units actually were. So it's just showing you an extra feature in the cloud, but it's quite a powerful system, if I can say that. What I'm going to do now is I'm going to prepare another sample. So forgive me while I go to this. Right. Because you're asking about, you did say sauces and you did say oils. So I just tested an oil pretty quickly. I could see there was not, oh my goodness. I could see that there's not much capsaicin in that. I just put a bit of sample in there, which I have just done. I will just get into a few things out of my way. By the way, we'll go back to the questions shortly as well. So don't fear, I will actually be going back to the questions. But I am going to prepare a sample super quick as well, which I will do by grabbing 100 microliters of that, which I am doing. I've grabbed the 100 microliters of that. I'm just going to grab 900 microliters of the buffer. And I will just do a quick preparation of the sample, which will be a 1 in 10 dilution. So let me just do this. Right, put that there, put that there. The nice thing about this kind of science that we do see is the sample prep can be actually quite quick. The reason being is a lot of things like HPLC, etc., require the samples not to be, you know, kind of cloudy the way this sample actually is. I am going to vortex this for a second. I do want to make sure that I don't lose track of this particular sample. I have a few samples in front of me. Right, I've got it prepared. I'll just put it there so I don't actually lose track of it. I'll take that sensor out. I'll just put a fresh sensor in. I'll do that. I'll do done on that. I'll just go to, I'm just going to call this, just going to call it source for a second so I can actually, whoops a daisy, so I can find it. Let me call it source 1, which I have now done. Right, so I should be fairly ready to run that. I'm just going to put 50 microliters of that sample onto the sensor, which I will do now. Just slightly thinking aloud, sorry if you hear me kind of stating the obvious a little bit. I'm just trying to keep track of multiple things at the same time. On it goes, good. Right, sample's on, let's go continue. Let's go start measurement. And as I say, I can actually see the raw signal coming in real time. I'm again not trying in this webinar, at least, to try and make you, be experts in this in a science called electrochemistry, but we do dig into this in quite a lot of detail during the monthly webinar. So there is one on the 24th of August. So this is giving me the Scoville heat unit now of a freshly prepared sample. I'm just going to turn it so I can just read it. Yeah, 5,520. If you Google the Tabasco source, you will find that Tabasco say that they ship between 2,500 and 5,000 Scoville heat units. I'd honestly say that within their era, this is accurate, that we are reading it correctly. Now what I want to show you is, I'm just going to share my screen for a second. So let me just go to what's called screen 2 here. I'm just going to go up to reports here. I'm just going to do a refresh here. I can see my source 1 data here, which is great. And I will open it up. Now remember, and there's the, then there's your date. I can see the date here, or sorry, the time here. I can see the date here. I can see the time here. I can see the date here. I can see who did it. So this is really good for kind of traceability as well. I did use the word transparency earlier on. You can see there's a high degree of transparency in this science. Boom! Look at these signals, right? Look at the way this is. You can already see that, in fact, this is actually a lot more intense. And I sort of said, oh, peak 1 for capsaicin, peak 2 for capsaicin, peak 3 for capsaicin. Bang, they are there, and I can see that signal. Don't forget, I prepared these 2 samples in exactly the same way. So you can already get a sense that, in fact, approximately, this is actually 5,000 Scoville heat units, this is 500 Scoville heat units. And you can see it in the raw signal. It's really important because people kind of come to us and say, well, I've been Googling about this particular chili and it's this hotness. It's not science. If you're pulling numbers off the internet, etc., or your expectations are built on taste or science, or I won't go on about HPLC for now. But what I'll now do is slightly change gears and just go back to the questions. So I did a quick demo on a sauce and an oil because I wanted to show you that yes, we can handle these samples, and it's super fast and easy to do. Right, now I'm going to dig into the question a bit more deep now. For example, if somebody made a 1% difference in their red chili in their formulation, will the device be able to detect it in the finished products? So I just want to run some maths on this. So let's take let's pretend we're taking a chili sauce that's made 60% of a pureed chilies. Now these pureed chilies have a wet weight Scoville heat unit of 50,000 Scoville heat units. I'm not going to use this webinar to go on about this, but people don't understand the difference between wet weight and dry weight. All the things that you see on the internet when they talk about Pepper X being 2.6 million Scoville units, that's dry weight. Often, actually, people then can have a dry weight expectation when in fact they're dealing with wet products. But theoretically, then, let's say we had 60% by mass of a chili sauce made up of a chili puree that had 50,000 Scoville heat units. That means the final hotness of this sauce would, for example, be 30,000 Scoville heat units. So let's just say that you were in your facility and you made a 1% error in the mass of the puree that you measured out. What would that mean? That would mean that, in fact, your final product was 30,500 Scoville heat units. First of all, I'm going to tell you that it's more than an opinion. The human tongue can't differentiate between 30,000 and 30,500. In fact, I'm having a conversation at the moment where somebody's got 2 products. One of them is 200,000 and the other one is 201,000. And they say to me, I can't believe that the other one's hotter than that one. It's like, no, but 201,000 versus 200,000, this is really not different. When you're measuring natural products, the difference of 100 or, the difference of 1,000 when you're talking about 200,000 is really no difference. But in this case, what am I saying here? You're asking me the question, could this instrument differentiate if you made a 1% difference? I'd actually argue that if you made a 1% difference in the measurement of a chili, in this particular example, you wouldn't even be able to detect that by your own taste buds, because it would actually lead to a 500 Scoville heat unit difference between the 2 products. In fact, I think that people are not really let me put it this way. Scoville heat unit range is actually 0 to 16 million Scoville heat units. If I broke this into 10,000 segments, I'm actually talking about 1,600 Scoville heat units. I actually think that if you're trying to distinguish between something that's 30,000 or 30,500 Scoville heat units, I think if you try to do this by HPLC, send the same sample to 2 different houses, you would get more than 500 Scoville heat unit difference between those 2 HPLC houses. our instrument wouldn't really pick up necessarily the difference between 30,000 and 35,500. I'll be straight about that. And I also don't think that the human tongue can't distinguish between if you make a 1% difference in this particular case. Now here I've been quite generous actually and made this situation worse by actually using something with quite a hot wet weight Scoville heat unit of 50,000. Some chili purees, a lot of chili purees are more like 20,000 Scoville heat units. So 20,000 Scoville heat units. So let's say that you've made this chili sauce up at 60% of 20,000 Scoville heat units. The final hotness of that product is 12,000 Scoville heat units. If you make a 1% difference, then the final hotness in that case will be 12,200 Scoville heat units. You absolutely will not be able to distinguish between 12,000 or 12,200, not by HPLC, not by this machine, not by your own taste buds. I bring this up because I think at ZP, I think we're the only ones really who are starting to, starting to bring this kind of chemistry logic to the world of chili testing. So the answer to your question is, can we distinguish a 1% difference? And I would say probably not. It gets easier the more intense the chili is. But if it's something like 20,000, it will only lead to a 200 Scoville heat unit change, and probably not is the quick answer. And neither will the HPLC, and neither will your own tasting be able to do that. Question number 2. So this is another interesting one actually, because I've been thinking this through for a while, and I'll sort of dive into it a little bit. So the two main isomers in the capsaicinoid family that make up the hotness of chilies is capsaicin and dihydrocapsaicin. Capsaicin has been given this nominal hotness of sort of 16 million Scoville heat units. Side note, I'm really wondering about who decided that this was 16 million Scoville heat units. I know who Wilbur Scoville is. I know the 1912 paper, but this has all been updated, and I'm really wondering who's updated all of this. But that said, dihydrocapsaicin has a Scoville heat unit of 50 million Scoville heat units. I'll be using these numbers now in my calculations. Okay, so let's make up this fictitious sauce that contains, by mass, 0.1% capsaicin. If by mass it contains 0.1 capsaicin, this bottle of chili sauce is about 16,000 Scoville heat units. And we're often testing chili sauces like this. These are not something that the consumer, this is not 16,000 Scoville heat units. But I do have, when I say artisan sauces that are made by kind of people who sell them at kind of local markets, and you get people who are really into chilies, those kind of sauces will start at about 16,000 Scoville heat units. But let's just pretend then that this mass of this chili is 0.1% capsaicin. That puree will end up being 16,000 Scoville heat units, because 0.1% of 16 million is 16,000 Scoville heat units. Let's pretend that in fact it's actually it's again 0.1%, but it's actually dihydrocapsaicin this time. So this means that this is 15,000 Scoville heat units. Now, in reality, you will find that at most the ratio, or rather the ratio maybe, it's very unlikely actually that it's 50-50 capsaicin dihydrocapsaicin. But if it was 50-50 capsaicin dihydrocapsaicin, the Scoville heat unit of that would be 15,500. I would like you to actually do a taste test and tell me the difference between a 16,000 sample, a 15,000 sample, and a 15,500 sample. What I'm telling you is that if it's 100% capsaicin or 100% dihydrocapsaicin or 50-50, you won't be able to tell the difference, at least through the taste test. Now, it's actually not often 50-50. It's sometimes more like 70-30. So if I have a 70-30 capsaicin, dihydrocapsaicin, let's say ratio, that will actually have a Scoville heat unit of 15,700 Scoville heat units. What I'm starting to show you is it doesn't matter if in fact, your sample is, all the heat is coming from 100% capsaicin, or all the heat's coming from 100% dihydrocapsaicin, or all the heat comes from a 50-50 split of capsaicin and dihydrocapsaicin, or it comes from a 70-30 split of capsaicin versus dihydrocapsaicin. And in fact, if I make it 80-20, which is probably more likely most of the time, this is only built up on experience, it's more like 15,800. What I'm saying to you is, and then you're getting down to a difference between 100% capsaicin and 80-20 capsaicin dihydrocapsaicin of 200 Scoville units. You will not spot that by HPLC, and you will certainly not spot that by your own taste. And again, the FoodSense Generation 4 will also struggle a little bit with that as well. So the reason I bring this up is because I think it's not having a go at anyone, but I do think that, at ZP, if you ask us these kind of questions, we will be able to give you the kind of mathematical explanation as to sometimes I think the people get very obsessed with ratio of capsaicin to dihydrocapsaicin. When you actually do the maths, it actually makes very little difference to the final products, especially when you think that most of the time the capsaicin to dihydrocapsaicin is in the ratio of probably 70-30, 80-20, 90-10. It really makes no difference. So, but at ZP, if you've got something unusual, then just run the maths by us. Now I'm going to go on to question number 3. They're asking the question, how reproducible and reliable is this? So the biggest source of irreproducibility in testing chilies, chili powders, chili samples, purees, is the sample itself. It's not the instrument. So let's say if we took 5 samples from a batch of chili powder. We took 5 samples and we prepared them every time. So we essentially end up preparing 5 samples. Nobody does this by HPLC. Why does nobody do this experiment? Because in the US it would probably cost you about $500. So it's just not, and I think the cheapest labs you can probably find about $50, but they're not necessarily, it's very hard to be scientifically vigorous at $50 a test, especially on an HPLC instrument. So I'm saying the question not is what is the reproducibility of our testing, it's actually what is the reproducibility of the sample, because in this particular case, all chili samples are heterogeneous. That means that there's not capsaicin evenly distributed throughout the sample. So in fact, in this case, we've got 45,000, 61,000, 53,000, 58,000, 50,000. The average was 53,778. And the standard deviation, if you're not sure about standard deviation, if you're a ZP FoodSense Generation 4 customer, I'm sure you are, fine on it. But if you're not, then, we can sort of quickly teach you. It's not super hard. The relative standard deviation, kind of which helps normalize this, which is just standard divided by average, is 12%. So I would suggest that we are often, when testing the same sample, 12% or better. Now, I know people say, oh, HPLC, I want 90. No, honestly, you don't want. I think HPLC is a test that you pay for. It goes off to a lab. You get a result back. You just accept it. There is never an error associated with that result. You get a result back with no error at all on it. And that is not the case. There is an error with every measurement that's ever made. It's just because people don't necessarily understand the HPLC method or understand that even an HPLC system has a reproducibility. You'll never have the error reported. So I will report that our relative standard deviation is 12%, and a lot of that actually comes from the samples itself. You did ask how we compared against HPLC. So this is not my data. This is a customer's data. So the customer took samples and they sent them off to HPLC, and they also tested them on the FoodSense Generation 4, and they got a correlation, a regression coefficient, I think that's what it's termed, of 0.99. So absolute perfect is 1. If you ever get 1, I've got 1 in my, I realize in my slides as well, but you don't get 1. It's super unusual. Now, so that's one of our correlations. This is a different lab, a different country, but the same thing. Test on the FoodSense, test on the HPLC. And again, we have an excellent correlation. But what I'm starting to realize is, and that's why I've stopped, I used to make a big point of, how we compare against the HPLC, but I've stopped doing it because I actually realized that when you do that, people believe that the HPLC is 100% accurate. But what we've actually realized is by comparing different HPLC houses, we're finding out that they've actually got they don't correlate well with each other. So this is a national lab, and this is another lab in a different country. If these two labs were correlated with one another, we would get the green line, but in fact we get the red line. So what am I saying? I'm saying if people are comfortable with HPLC and they can afford it and they can get all the testing done that they need, then they should definitely stick with it. If you're looking for a much lower cost, much faster, I would say transparent and also a very high degree of traceability, then that's when the FoodSense Generation 4 really comes into its own. I would super argue that this is super simple to use. It's a bit of a pun, but it literally is child's play. So it's small, it's definitely smaller than the HPLC. It's easy, it's definitely easier than the HPLC. It's fast, it's definitely faster. I mean, I think I can prepare and run a sample quicker than you can probably package a sample to send out to a lab. It's also cloud enabled, and that cloud enabledness means that we can see the raw signal. I think it'd say we've got the receipts, and what I mean by that is we don't just give a result. Here's a result on my phone, but we don't just give the result. We actually get the raw signal and put it in the cloud. We got who did it, when they did it, what date they did it, what the raw signal looks like, and the results. We can always defend these results. So sometimes I get people sending, well, this is my certificate of analysis. A certificate of analysis from HPLC house is a number. Behind that number is a chromatogram. Behind that chromatogram, there's also a calibration routine. And behind that calibration routine is a date and time when that calibration is done. Most of the time, all you actually get is the number. You have none of the back of house processes that have gone towards making that number. So it's a little frustrating that actually people do actually sort of hold on to a genuine belief in the HPLC. But I think to myself, why are we selling so many of these FoodSense Generation 4 if the HPLC is actually the kind of, let's say, the perfect tool? But I think in essence, this particular questioner is asking a very fair question. So I therefore describe it as a screening tool. And you can, if you want, still use HPLC. But you'll get correlation with HPLC, but I would suggest if you sent the same sample out to several HPLC houses, you'll definitely come back with a bigger error than you were, or difference between those HPLC houses than you were otherwise expecting. So if you've got any questions from ZP, don't hesitate to reach out to us, and we'll do the same thing next week. So send in those questions. Okay, thanks very much.